The problems below walk you through the derivation of Simpson's rule. Remember that we have to compute the area under a parabola. Let's recall the setup. We start with a function f of x. We divide the interval into two pieces. Call the left endpoint x0, the midpoint x1, and the right point x2. The distance between each of these points is delta x. We call the heights of the points on the curve y0, y1, and y2 respectively. The idea behind Simpson's rule is to approximate f of x over this interval with the unique parabola y is equal to ax squared plus bx plus c that goes through these 3 points on the curve. At this point, you might be a bit worried because you think that this parabola doesn't really look like a very good match for this curve. But remember that we will be applying this rule over very small intervals. So this piece of curve that I drew here is rather unrealistic, or maybe it's better to say rare. Over a very small interval, our curve is unlikely to change curvature so drastically. Now, since the area under this parabola doesn't actually depend on the x-coordinates, we can translate it to the left or the right, and we won't change the area. In order to simplify your calculations, we're going to let x0 equal negative h, x1 equals 0, and x2 equal h. This symmetry is going to help you greatly in the problems that follow. Now, with these coordinates, using the fact that our delta x is now h, your goal is to show that the area under this parabola is given by h over 3 times y0 plus 4y1 plus y2. Have fun and good luck.